Hello, everyone. We are students of SPIT, Sardar Patel Institute of Technology. I'm Diksha. Today we are going to present and explain our project titled Temperature-Controlled DC Fan, which automatically turns on when the temperature rises above a preset limit. Introduction. This project is based on four main blocks: temperature sensing signal amplification, comparison and decision-making relay-based fan control. The aim of this system is to monitor the surrounding temperature and activate a DC fan only when needed, saving energy and improving cooling efficiency. 1. Temperature sensing, LM35. The heart of the circuit is the LM35 temperature sensor. It gives 10 millivolts per degree Celsius, so at 30 degrees Celsius, it gives 0.30 volts. At 70 degrees Celsius, it gives 0.70 volts. This small and precise voltage becomes the input for the rest of our circuit. The LM35 output is connected to a transistor through a resistor. This transistor, Q4, acts as a small signal amplifier because the voltage from LM35 is too low to directly control the circuit. 2. Amplification stage, Q4 transistor. The signal from LM35 is fed into Q4, a BC547 transistor. Its job is to boost the sensor voltage so that the comparator section can detect the increase more clearly. As the temperature rises, Q4 conducts more, and the amplified voltage is passed to the next block. This ensures the system responds quickly and accurately to temperature changes. 3. Comparator and decision stage, Q1, Q2, and resistors. Here comes the brain of the project. This section compares the actual temperature voltage from Q4 with a preset reference voltage created by resistors R4, R5, and R7. The reference voltage represents the threshold temperature. For example, if the threshold is set to 45 degrees Celsius, then only when the LM35 voltage goes beyond that level will the circuit activate. How the comparison works. When temperature is low, Q1 stays off. Q1 off means Q2 is also off. So the fan remains off, but when temperature crosses the threshold, Q4 sends a stronger voltage, Q1 turns on Q1, then activates Q2, and Q2 passes the signal to the relay driver stage. This is how the circuit decides when to switch the fan on. 4. Relay driver and fan control, Q3 plus RL, 1. Once Q2 turns on, it activates Q3, another BC547 transistor. Q3 works as a relay driver because the relay needs higher current than the previous transistors can supply. When Q3 turns on, the relay coil energizes relay contacts close, and the DC fan turns on automatically. A diode across the relay, D2, protects the transistor from voltage spikes created when the relay switches off. This is known as a flyback diode. 5. Noise filtering, C1 and D1. At the end of the circuit, we have a capacitor C1 and diode D1. These components help remove noise and prevent the relay from turning on and off rapidly. This ensures smooth and stable operation. Summary. So, overall, the sequence is LM35 senses temperature, Q4 amplifies the signal, Q1 and Q2 compare actual temperature with the threshold Q3, drives the relay switches, on the fan when temperature gets too high. This simple yet effective circuit is useful in electronics, cooling, battery temperature, monitoring smart home ventilation, industrial control systems, closing. This was our 4-minute explanation of the temperature-controlled DC